I've thought about making a video about this device several times before and finally decided to give it a go as it might give someone some inspiration to make one of their own. I've been unhappy with it for a number of reasons. For a start, strictly speaking, I never felt it was finished. The oscillator, for example, is a completely separate unit. The main board has redundant LEDs and one of the switches isn't used. And yeah, the user interface is pretty awful. Yes, I know I wrote it, but my reason for leaving it like this is because it was only meant for me to use, and tidying it up was therefore a pointless exercise. When I decided to learn the Morse code, I came up with this idea as I had several working microprocessor-based boards kicking around and waiting to be used for something useful. This one I modified to use the standard Hitachi chipped LCD display, adding a simple keypad with 4 switches, one of which is never used, plus a reed relay because I have a box full of them to drive the audio oscillator I was planning to use. My embryonic idea was to build a device you could program with just the characters you want to learn. In the end, I incorporated a choice of all letters and numbers plus 4 punctuation characters. Maybe if I were making a more commercially styled model, I'd have included all current Morse code characters and phrases. The device could then be used to choose characters you want and transmit them on an oscillator in a pseudo-random order. At the same time, it would make a line of characters on the LCD display, which can be checked afterwards against the pencil and paper version which you're making while you are listening to it. I've given the device 2 transmission speeds. One is slow and one's very slow, although it says fast and slow actually in the program itself. If somebody were to remake this, all they do is change the delays if they want to do it a bit faster, for example, but I felt no, for me, I was just initially learning the characters. It didn't matter whether it's really slow or ultra slow. Yeah, it takes, unfortunately, a long time to actually program the thing because you have to use these keys. You go through the entire character set and you say yes, no for which characters you want. But it does work. And if you've actually put in the ones you want, you don't have to go away to the end. You just press the reset button and it will store the ones that you've already decided and it will bring them out of the RAM. You'll notice that we have a non-volatile RAM here, means that we can turn it off, go away, come back next week. Obviously one wouldn't when one's learning, you don't do it next week. And you can use the same ones all over again because it stores them in the non-volatile RAM. In order to demonstrate this quickly, I've already put a set of a few characters inside the memory. We'll turn on in a minute and you'll actually see it working. All we'll hear is, it's not a very good bleeper, this thing here. You'll hear the bleeper sounding the Morse code, which we'd obviously write down a piece of paper. We don't look at the display at this point because that's compared at the end. And you'll see how it picks up a random selection of characters. So if I start on by turning it on, now we come up with the terrible user interface, which is selecting the speeds and things. So we have to do this one, no, and then we want the C, which is that one, the slow, yes please, because it's the bottom one. Then we press D again, and start, well, as soon as we hit the button here, we'll then have the Morse code. Now what Morse code I've chosen to run for this one, the characters in here, is A to H, so that's A, B, C, D, E, F, G, H, and 1, 2, 3, 4 from the numbers portion. So if I let it run, we'll see it start. See, we're having the actual characters coming up. What I'll do is I'll skip to the end. That's it. The end light has come on the computer down there. You can see that the red one here, which means that the sequence has finished. It's now simply a case of comparing these with what you've written down on your piece of paper and checking and seeing if these are the correct ones that you've put down. So quickly, let's have a look and see what happens if we actually want to program it. Let's just do something very simple. So if we reset works for a lot of things. Clear memory, and this time we're going to say yes. So we do that, and now it's going to come up with each character in turn we can choose. So if we choose, basically by holding the no, this is the no one, it then goes to the next one, and you see it will keep going until you find whichever ones you want. So what I'll do is I'll pick something simple like JKL or something. Right, so do we want J? Yep. Do you want K? Yes. And you want L? Yes. Now I'm just going to hold this down and say no for the rest, and I'll do 5, 6, 7. So I'll just let it run right to the end. 5 will have, 6 will have, and 7 will have. Now you can either let it run right to the end or press reset. Reset will hold the numbers that we just picked. So that's it. So we've gone back to the beginning. So we don't want to clear the memory this time, which is a D. And let's try again. Now when we do it, we should see the new programming we've just put in. See, and this is just using the numbers we put in, and letters of course. So it allows you to choose which ones if you're not sure about. JKL, and it was 5, 6, 7 if you remember. So you can see it's bringing them up in a pseudo-random order. There we go, that's the end. What I'll do is I'm going to link down below where they actually are a collection of files showing the circuit, the program, and other notes about it. If anybody's actually interested, I'm not sure anybody will want to build this particular one because it's a bit quirky, as you can tell, but it might give somebody an idea to make something for themselves. If anybody has any questions about it, please feel free to ask and I'll see if I can answer them. Thanks for watching.